Assalamu alaikum. I hope you're all doing well. This is Safat Khan on the stream to office. So let's do a fraction of differentiation. A company makes drinks and containers out of metal. The containers are modeled as closed cylinders with base radius r centimeter, height 8 centimeter. Capacity of each container is 355 centimeter cube, which is the volume given. The metal used for circular base in the curved side costs 0.04 pence per centimeter squared, and for the top costs 0.09 pence per centimeter squared. So this is the top, and this is the base as well as the curved side. Both uh, metals used are for of negligible thickness. Okay, so show that the total cost C square pence of the metal for one container is given by this equation. Total cost of one container. Now remember one thing, total cost is going to be the cost of the base plus the top plus the curved side. Do we know about the base now? The base has a radius of this much, so because it's cylinder, so it has to be circular, so it has to be pi r squared. This is the area of the base. Then what about the top? Top is also the same, right? It's also going to be cylindrical. It's also going to be circular, so it's also and because it's a cylinder, so top and base have the same radius, so it's also going to be pi r squared. And if that is the curved side, what's the surface area of a cylinder? Curved surface area of a cylinder. The formula for that is 2 pi r h. Okay, 2 pi r h is the formula. What's the height? Height is h. 2 pi r h. That's the total area. Now, circular base and curve is 0.04. The meaning pi r squared will also be multiplied by 0.04, and the 2 pi r is also multiplied by 0.04. And the base and the top is 0.09. So that part 1 millimeter by 0.09. Add them together for 0.13 pi r squared added to. Okay, with 0.04 uh, multiplied by 2 pi, 0.85, 0.8 multiplied by pi will be 0.08, sorry. Okay, so this is something, but let's just keep it in 2 pi for now. 2 pi RH. Okay. Now we do know the volume. That one container. We need to convert this height somehow into this form. So for that, what we need to do is we need to use the volume of the cylinder. Volume of cylinder equals pi r squared h. So this is 355 equals pi r squared. So h can be rearranged to form 355 upon pi r squared. Take the h and put it back into this equation. Okay? Take the h and put it back into this equation. This is going to become 0.13 pi r squared r into 2 pi multiplied by 355 over pi r into r. Pi r squared, sorry, over pi r squared into r. Yeah, so r squared and r cancels out, pi and pi cancel out. 355 into 2, and there's a 0.04 as well right next to that, right? 355 times 2 times 0.08, and therefore, let's multiply these. This turns out to be 28.4. What are plus 0.13 pi r squared. The hence proof we found this equation. Once we reached here, use calculus to find the value of r when c is minimal. Give your answer to three significant figures. Now, part B, when we know that c equals 0.13 pi r squared plus 28.4 over r, it says find the value of r, right? Simply no, that's minimum. Okay. So for this, we differentiate this equation with respect to r. So Pc would be r equals 0.26 pi. Okay, and for this, we apply the chain rule. We have an r left over here. Okay. Once we do that, we equate this whole thing to 0 because when c is minimum, what will be the gradient? Minimum means stationary point, right? Gradient will equal 0. So when we try to find out the value of r, now let's simplify. This is going to be actually, let's simplify further. R comes out to be just a second. R turns out to be 3.263, but just keep it as 3.26 because we need the answer to 3SF centimeters. Okay. Yeah, it's correct. Then after this, the part C says Using d squared c over dr squared, prove that the cost is minimized by the value of r found in part B. Okay, now d squared c over dr squared means we need to do a double differentiation of what we've gotten. So to double differentiate this, this is going to be 0.265. The other one is going to be right here with the value of r in here. Actually, wait, there's actually a mistake right here, but it doesn't really matter. It doesn't change our results. Still, I'll correct it for the sake of completeness. The results are still going to be the same either way. So let's correct the differentiation over this. This is going to be 0.265. And the second number has to use the chain rule. So first number is differentiation, second as it is. Then minus and minus now becomes plus. Second number is differentiation, first as it is. Upon second squared. Now r cancels out to form r cubed. This becomes 0.265 added to 2 times 28.6. So 50, 2 times 28.4, so 6.8. You simplify this further. Just the value of r which we calculate is 2.26 cube. Calculate this piece. This turn out to be 2.46. 2.46 is a positive number. This means d squared c over dr squared is greater than 0. Hence it's proved that yeah, it is minimized. The cost is minimized from this value of r. Okay. Okay. The next is let's find the minimum value of c and giving your answer in the to the nearest integer. So for that, what we need to do is we need to just take this equation Okay, put the value of R in it to get the value of C. And because we've already established that this is going to be the minimum value of C, the value you get is going to be the value of um, minimum value of C. Let's put it in there. So 3.1. So yeah, correct. We got our answers. So this finishes off this question on differentiation. Thank you so much for watching. Meet you in the next video. Please do subscribe and support our channel.